All right, so before the break, we talked about adding or addition equations. Today, we're going to talk about subtraction equations. All right, so we're going to be on page 8. And again, this is what we did in class. So if you were absent, this is what you would have missed. And this is what you would need to catch up on. Here we go. We're going to start with some models here. And this one's a little hard to show, but we have x minus 2 equals 3. I'm just going to jot that down. X minus 2 equals 3. So that means like if I do like a division line here, this side's equal to 3 and this side's also equal to 3. Excuse me. So here we have three holes, right? 1, 2, 3. On this side, we have an unknown number, but we know we're taking away 2. And the models for these are not like, we're not going to be using models. I just wanted to show you, again, what this might look like in a model. So this says we're subtracting 2. These 2 are gone. We subtracted them. So how many would we need to get to 3? So that mean we need 3 more. 1, 2, 3. So the answer to this question is, well, what did we start out with in this group to get to 3? We started out with 1, 2, 3, 4, 5. Then after we subtracted 2, we wound up at 3. So the solution would be x equals 5. Again, that model doesn't make 100% sense. That's okay. We're not really going to use models, but I wanted to show you what it would look like. All right, let's solve it using symbols, which is going to look more familiar to us, but we still should get x equals 5. So the first thing I'm going to do is write down the equation, just like we did before with the addition ones. We're going to do a little barrier here to separate the sides, show both sides. And we're going to do the inverse of subtraction because we want to get rid of all the numbers or any number that is near the variable. So we have to undo the minus 2. We're going to do that by adding 2. If I do it to one side, to keep them both equal, both sides equal, I have to do the same thing to the other side. So we're going to add 2 to both sides. Well, what happens here? We have a minus 2 and a plus 2. Those cancel out, and we're left with x equals, well, what's 3 plus 2 would be 5. Now we have to check it. So let's check it. Hopefully 5 works. I think it does because this one's, again, really straightforward. There's a 3-step check. We'll write it down first. Next step, try out the number of our solution. 5 minus 2 is 3, and 3 is equal to 3, no doubt about it. That checks out. So again, we're going to be using this method, not really the models. So again, if you didn't like the models, that's okay. That's okay. All right, so let's try these here. It says, solve each equation, check your solution. Okay, let's do it. So first one here, let's solve it. First thing I'm going to do is write the equation out. Next thing, I'm going to do my little barrier here, show both sides. I want to get rid of the minus 7 because it's near the x. Whatever's near the x, I want to get rid of. I'm going to do the inverse, the opposite. We'll add 7 to both sides. That's going to cancel out the 7s. Minus 7 plus 7, those go away. We're left with x, which is what we want. 4 plus 7 is 11. So it looks like 11 is our solution. But let's just check it. 3-step check. X minus 7 equals 4 is the first thing. Write down the equation. Then instead of x, we're going to put 11 minus 7 equals 4. Now this is something we can do in our head really easily. 11 minus 7 would be 4. And 4 is equal to 4. That checks out. So our answer, our solution was x equals 11. Nice. This one's a little different, has decimals, but again, the same exact steps are involved in this one as well. First step, we're going to write it down. First and easiest step, write it down. Put a little barrier here. I want to get rid of the minus 6 4/10, so I'm going to add 6 4/10 to both sides. Okay. What happens here is the minus or the subtracting 6 4/10 and the adding 6 4/10, those cancel out. And we're left with y equals 1 plus 4 is 5. 8 plus 6 is 14. So it looks like our solution for now is 14.5. But you know what we're going to do. We're going to check it. We're going to check it. So that looks to be it. It's a 3-step check. We'll write down the equation. We'll see if 14.5 is indeed the solution. We'll put in 14.5. Okay, off to the side here. I'm just going to check this real quick. 14.5 minus 6.1. It's always good to check it just to make sure. 5 minus 1 is 4. 14 minus 6 is 8. Oh, I put the wrong number down. Swapped them out. That is 8.1 or 8 1/10. So that checks out. That checks out. All right. Feeling good. Now this next one might look like, oh, by the way, the solution, the answer, y is 14.5. This next one might look really complicated because it has fractions, but really it's the same steps just with fractions. So we're going to write it down first. 1/5 equals a minus 3/5. Now, same barrier there. And the same goal. I want to get the a by itself. Right now we have a minus 3/5. We're subtracting 3/5. We want to undo that. We want to get rid of the minus 3/5. So we're going to add 3/5 to both sides. Again, this is sort of the same deal as the previous ones, just that these are fractions. We're going to add it to both sides. So the minus 3/5 and the plus 3/5, those cancel out. And all we're left with is a. 1/5 plus 3/5 is 4/5. And that is a. So 4/5 is a. But you know what? Let's just check it to make sure. 3-step check. We'll write the equation. 1/5 equals whatever a is minus 3/5. Well, we got 4/5 for a minus 3/5. Let's just check that real quick. 4/5 minus 3/5. Yeah, that would be 1/5. So that one's pretty straightforward. So our solution is a for this equation would be 4/5. All right, now I'm going to share with you a trick that will help you write subtraction equations. For any subtraction equation in 6th grade, this is what it might look like. So what it looks like is this. We have a variable minus a part equals another part. And the nice part about subtraction equations, it doesn't matter what number you put in which spot for subtraction. Because to undo subtraction, we're going to add, which is, the commutative property of addition says that you can change the order of the numbers and get the same answer. So even though this is a subtraction equation, we're going to use addition to solve it. So it doesn't matter which part goes where. So this is what a subtraction equation is going to look like. This is going to help us solve this question here about space, it looks like, about astronauts. At age 25, German Titov of Russia was the youngest person to travel into space. This is 52 years less than the oldest person to travel in space, John Glenn. How old was John Glenn? Write and solve a subtraction equation. They tell us it's going to be a subtraction equation. It's going to look probably something like that. All right, first we need a let statement. Well, what are we trying to find? The question is, how old was John Glenn? So I don't know. Let J equal maybe John Glenn's age. John Glenn's age. So it's going to look like this. The variable minus a part equals another part. So we'll start with J. That's the variable. Now, what are the parts we're subtracting here? Germain Titov was 25 years old. That's 52 years less than John Glenn. So if we take John Glenn's age and subtract 52 years, that would give us Germain's age, I think that's how you pronounce it, of 25. So John Glenn, who's older, if you take away 52 years, subtract it, you should get his Germain's age, 25. So I'm feeling good about that. Notice, variable minus a part equals a part. Now, if we did J minus 25 equals 52, we'd get the same answer, which is nice about subtraction equations. All right, so we'll do the little barrier. We want to get rid of whatever is near the J, which is a 52. So we're going to add 52 to both sides. Do the inverse, do the opposite. Minus 52 plus 52, those cancel out. You're left with J. See how old he was. 25 plus 52, 77. Allegedly, we got to check that real quick. So it looks like he may have been 77. So we have John Glenn's age minus 52 years equals 25. Next step, we'll put in the 77. That's what we got for J at the moment. Minus 52 equals 25. Off to the side, I'm just going to do this real quick. 77 minus 52. I'm pretty sure it's 25. And it is. So 77 minus 52 is 25. That equals 25. So what's the answer? The solution is 77. So the answer is, I guess I'd write it right here. So John Glenn was 77 years old. That's pretty good. That's pretty good. Impressive for a 77-year-old to go into space. Nice. So this is our solution. That would be our answer. All right. Let's keep rolling here. We're on page 8. We're going to page 9, believe it or not. Let's talk about Georgia. The person, not the state. We got George. Oh, by the way, before we do this, I'm just going to write that little tab. I want you to write this again. Oh, I crushed the pencil. Here we go. Variable equals, for a subtraction equation in 6th grade, variable minus the part equals another part. That's how you write a subtraction equation in 6th grade. It says George's height is 4 inches less than Sienna's height. Georgia is 58 inches tall. Write a subtraction equation to find Sienna's height. Okay, so I'm thinking here, who's taller? Georgia's height is 4 inches less. So that means Sienna's tall. I just want to get a sense of that. So Sienna's taller. Write a subtraction equation to find her height. So that's what we're looking for. So let's write a let statement. We'll let, I don't know, S equal Sienna's height. Okay. Okay. So to write this equation, again, a 6th grade subtraction equation will look like this. So variable is S minus, all right, what are the parts here? Georgia's height is 4 inches less. So if we take Sienna's height and subtract 4 inches, we should get Georgia's height, which is 58 inches. Now here's the thing too. If we did S minus 58 equals 4, we get the same thing. So that's why it doesn't matter what order you put the parts in. As long as you have a variable minus a part equals a part with a subtraction equation, you're golden. You're golden. With addition, it's a different story because it matters the order there. All right, let's do a little line here. Let's find out Sienna's height. So we're going to add 4 to both sides to get rid of this minus 4, or subtract 4. Okay, 8 plus 4 is 12, 5 plus 1 is 6. Sienna, and these cancel out, Sienna appears to be 62 inches tall. So that'd be 5'2". All right, let's check to make sure that's actually the case. So we'll rewrite the equation. Expression has no equal sign. That's why we call this an equation, because it has two parts equal to each other. An expression would just be something like that. So it'd be 4 less than Sienna's height. That would be an expression. But here's an equation. S is 62 minus 4 equals 58. This is, again, one that you might just be able to do in your head. 62 minus 2 would be 60, and then minus another 2 would be 58 equals 58. That checks out, but we need an answer for this because it is a word problem. Find Sienna's height. Well, Siena, which is, I believe, a city in Italy. Siena is in a college in Albany, so there you go. A lot of history for Siena. Siena is 62 inches tall. I believe the Sienas, both Sienas have only one end, though. Just a fun fact there. All right. Okay, perfect. So now we're just going to do 3 more here, these 3. If you want to try these on your own, go for it. But let's try these here. Again, we're just going to practice some subtraction equations. A minus 5 equals 9. We'll write it down. Do a little barrier. We'll add 5 to both sides. Plus 5, plus 5. Minus 5 plus 5 cancel out. That's why we added 5. A equals 9 plus 5 would be 14. So our solution to this appears to be 14. But of course, we can't say we're done until we check it. Here we go. Let's check it. Write it down. A minus 5 equals 9. We get A, we got 14 minus 5 equals 9. Well, 14 minus 4 is 10. 14 minus 5 would be 9 equals 9. So our solution, our answer would be A equals 14. All right. So again, you can try these next 2 on your own, but you can also do them with me. Let's try this out here. We got B minus 13 and 1/10 equals 7. Okay, so this one's going to be good. We're going to do a little barrier here. We have to get rid of the minus 13 and 1/10. We're going to add 13 and 1/10 to both sides. Now the key thing is we got to line up the decimal places. So I'm going to put a decimal point. I'm going to annex a 0. So we can line up the decimal points, because when you add or subtract decimals, you got to line them up. Line them up. That was unit 1. Unit 1. Minus 13 and 1/10 plus 13 and 1/10. Those cancel out. You get B equals, well, let's add these up. 0 plus 1 is 1. Bring down the decimal point. 7 plus 3 is 10. 1 plus 1, believe it or not, is 2. 20 and 1/10 for now. We'll see if that holds up here with the check. B minus 13 and 1/10 equals 7. Well, B we got is 20 and 1/10. Now, this one's not too bad. So 1/10 minus 1/10 is 0. The decimal places kind of just go away. 20 minus 13 would be 7. So it's just 7. If you line those up, subtract them, you just get 7 equals 7. That checks out. That means 20 and 1/10 is in fact the solution. We got it. All right, last one here. Last one. 2 sevenths equals R minus 3 sevenths. Okay, let's do it. So we got 2 sevenths. I'm going to write this kind of small because it's hard to fit these fraction ones in here. Okay, same rules, just now with fractions. Do a little barrier here. Now, because the variable is on this side, the right-hand side, we're going to focus on this side first. We want to get rid of the minus 3 sevenths that's hanging around the R. So we're going to add 3 sevenths. Whatever's hanging around the variable is what we want to get rid of. Plus 3 sevenths on this side. Both sides are the same. The minus 3 sevenths, the plus 3 sevenths cancel out. And we're left with R equals 2 sevenths plus 3 sevenths would be 5 sevenths. Okay, that seems to check out. Last but not least, We'll see if that's true. Here we go. Set 2 sevenths equals r minus 3 sevenths. 2 sevenths equals, instead of r, we'll put 5 sevenths minus 3 sevenths. All right, let's check this out. 5 sevenths minus 3 sevenths. That'd be 2 sevenths. So, I mean, again, that's one that you could do in your head there. And that checks. So the answer, the solution would be 5 sevenths. All right. So we're actually going to finish the bottom two on another video. So that's all that you missed today. I hope you have a great day. If you have any questions, feel free to let me know. And I'll see you soon. Bye-bye.